Recursive Routines, the first lesson in a new unit on functions. As I often say, think about my class as a video game, where you travel to each different world trying to conquer it, and each unit represents a new world, where you start easy and you work your way up to the boss at the end of the world, and then you can advance to the next world after you're done. Similar to Super Mario for the Super Nintendo, my favorite video game system of all time. All right, recursive routines. Make sure you have your Desmos calculator out. I'm going to leave up this simplifying fractions calculator in case we need it, but probably won't use it too often. I don't know if I'm going to use it at all during this assignment. But dive right in. This is a fun lesson because humans, by nature, are pattern solvers. If you enjoy games, puzzles, heck, any video game, really, you're solving a pattern, you're completing a quest. This assignment is a good example where we're going to do that. You could see on your screen, you have blanks that you're going to fill in. 10, 20, blank, 80, blank, blank. Some problems you could fill in with addition, some multiplication, division, subtraction. For this assignment and this unit, we're only going to focus on multiplication. So each one of these numbers, as you go from left to right, is going to multiply by some number to get the next one. And that pattern is going to stick. So whatever you multiply 10 by to get 20, is whatever you're going to multiply 20 to get this blank. It's whatever you're going to multiply this blank to get 80, and on and on. Our start value is always the first number on the left. And sometimes we'll have to solve for that. But the very first number here, like 10, that's my start value. So you can start by typing in the value that you see on the left. Then we need to figure out our constant multiplier. 10 times what is 20? You might have already filled this in. You might be screaming it at the computer. But in case you don't know, here's what you do. You take any two numbers right next to each other. So they could be, if we had 2 over here, we'd use these two. Any. And you do the right number. I'm going to write this out. Write this out. Gosh, so many puns. You divide from right to left. So I do 20 divided by 10. And if you don't know what that is, this is why you have your Desmos calculator on your right. 20 divided by 10. 2. So that is my constant multiplier. And what that means is that as we go from left to right, if we just keep multiplying by 2, we will get all of our answers. So let's do that. We start with 10, 20, so we need the next one. So I do 20 times 2, 40. 40 times 2 is 80. 80 times 2 is 160. 160 times 2 is 320. If we have our graphing calculators in class, there's a really nice way where you just keep mashing the enter button and it keeps spitting out the next term. But for now, we'll do them manually. RIP, I miss you, graphing calculators. If you're in class watching this video, enjoy that graphing calculator. I'll teach you in class how to use that. Okay, number 2, we have, now our two numbers next to each other are here. So I'm going to do 448, remember, right divided by left, always. 448 divided by 112 is 4. So my constant multiplier, 3, 2, 1, closing this out, is 4. Remember, my start value is my first number. That's just 7. And then I can multiply these by 4. 7 times 4 is 28. 448 times 4 is 1792. And 1792 sounds like an important American year. Times 4 is 7168. 7,168. Okay, now we're cooking. 2 problems in, 6 to go. We're a quarter of the way through. All right, now we have our start value as our first number, 4. Constant multiplier. Let's close out of these. I've got right divided by left. So 48 divided by 4. 12. And then I need to figure out my 6th term in the sequence. Well, 576 is my 3rd term. 1, 2, 3. So let's see. What's 576 times 4? So 2304 is my 4th term. And then 9216 is my 5th term. And 36864 is my 6th term. And let's see if I counted correctly. Oh, I did not count correctly. Dang it. Oh, I need to go one more. I really miss my graphing calculator where you could just like type enter in as many times as you need. Let's do this one more time. 6, 18. All right. I'm going to be very, very concentrated now. I need the 8th term. 54 is my 3rd term. My multiplier here is 3. 18 divided by 6 is 3. Okay. So 162 is my 4th term. 5th term. 6th term. 7th term. 8th term. All right, 2nd time. Okay. Man, I miss my graphing calculators. Makes this so much easier. All right, right divided by left. My two numbers next to each other now are 5,000 and 500. So right divided by left. I get 10 is my constant multiplier. A reminder, if you multiply something by 10, you're just simply adding a 0, or you're moving that decimal point to the right. So that makes sense. All right, my start value I don't have. Well, I can multiply this by 10, which means add a 0. So I've got 5,000. Just add in a 0. I could take away a 0. And there are no zeros left to take away. So here's what you do. You know that your multiplier is 10. So as I said, each time that means we are multiplying by 10 to go from left to right. It also means that each time we go from right to left, we divide by 10. So if I do 5 divided by 10, I should get my first number, or my start value. 5 divided by 10, maybe you could see it. If I move the decimal point over one spot from 5, I get 0.5. And I don't even think you need the 0. You almost never do. So divide by your multiplier when you go from right to left. Beautiful. Love all those green check marks. All right, here we go. I get to conquer my my nemesis of counting the 7th term here without my graphing calculator. So 5, right divided by left. So I'm going to do my 2nd term divided by my first. 12.5 divided by 5. I get 2.5. Then I need to do my 7th term. Okay, I can do this. I'm going to eventually round to the nearest hundredth as well. I'll remind what that is at the end. Okay, 31.25 is my 3rd term. I can do this. Times 2.5 is my multiplier. All right, so this is my 4th term. Can I just copy and paste this? Let's just do that. Copy. Paste. So this is my 5th term. Copy. Control C and Control V is what I'm doing out here on my Mac. 6th term. And 7th term. All right. Let's round to the nearest hundredth. Little review about hundredth. Hundredth is the 2nd spot. Ooh, that's tough to see. Let's make it a little bit. There we go. So I'm either going to round this to 0.71 or it's going to stay 0.70. The key is I look at my 3rd number, the number to the right of the wall. I could ignore everything else so I don't double round. If this number to the right of the wall is 5 or above, then I give it a shove up to 71. But if it's 4 or below, which includes 3, 4, 3, 2, 1, 0, 4 or below, then I leave it alone. Nah. So 1220.70 If you have a 5 or above, round it up. Give it a shove. Come on, I do not want to have to redo this one. 4. That's the wrong one. 1,220.7. Oh, I could probably also just put 0.7. Please be right. Yes. Whoa. Never been so relieved and joyed to see that green check mark. All right. Maybe my favorite problem of the entire year. And I know I say that a lot in terms of the assignment, but this is for the whole year. All my classes is this problem right here. And here's the situation. Mary is a troublemaker. She's what some call a hoodlum. She pushes boundaries. She doesn't like listening to rules. She gets sent to the principal's office every day, sometimes multiple times a day. Her parents have no idea what to do with her. So they think, what if we try to make her a deal that sounds good and it just saves us money? Because we're tired of giving Mary money for her allowance when she's always getting in trouble. So here's the deal. Instead of giving her normal like $5 for the week, they're going to give her 8 cents. Now that might sound like a terrible deal, but here's the catch. Her father told her that he would double her allowance each week she did not get a referral at school. So any week you don't get sent to the principal's office, you get your allowance doubled. So we're going to calculate what she would get paid for the first 6 weeks, and then it's going to get really fun because Mary, again, she's street smart. She's getting in trouble just because she likes getting in trouble. She's secretly a good kid on the inside. She knows if she stays good for just a few months, her parents are going to have to pay her so much money, and this is going to inspire her to not get sent to the principal's office anymore. All right, here we go. Always start in these problems with week 0, and then the easy part to start off is just filling it in by increasing 1 each time. So 0, 1, 2, 3, 4, 5, 6. Week 0 always represents her initial allowance. So in my case, it's 0.08. I don't need the 0 in front. For you, though, make sure you type in your answer. Some of you might get paid 5 cents an hour or 10 cents. Just type in your problem, not mine. Then we're going to have to start doubling. So 0.8 times 2 is 1. Oh, I need 0.08. Don't make that mistake. Make sure you type the 0.08 instead of 0.8. That's a big difference. So she gets 16 cents. And if I just type times 2, does the A and S work? See, in my graphing calculator, I can just keep hitting enter, and it's going to automatically give me my answer. And this is going to be a really annoying problem to type in manually. But I will do it. I miss you, yellow graphing calculator, so much. 0.32 times 2 is 0.64. 0.64 times 2. 1.28. So now she's making over $1 by week 4. Again, seems small. It's not her normal amount, but just wait. 1.28 times 2. 2.56. By week 6... So that's about a month and a half. She'll be making over her $5. 12 cents profit. And her parents are starting to get nervous. They're like, oh my gosh. I hope she gets a referral this week. We don't want to pay her over $10. Well, just wait. Mary's not getting a referral for a long time. Next question says, does her allowance from week to week form a geometric sequence? That means, are we multiplying the same number each time? Well, yes, we are. And we start with our start value, but then our multiplier is 2. To double something means to multiply by 2. All right. This is where it's going to be fun, but also very tedious without my graphing calculator. I'm going to have to count and be very, very careful with how I count. I'm almost assuredly going to mess this up. We are on week 6. Mine says I need to get to week 19 and see how much of that sweet, sweet cheddar Mary is going to bring in from her parents that week. So let's do it. 512 times 2. So this is week 7. Week 8. Week 9. Week 10, she's bringing in $80. 11. 12. 320. 13. 14. She's broken $1,000. 15. 16. 17. She's broken 10 grand. Her parents are taking out a second mortgage on their house as they type in the next one. I've lost count, but I'm going to have to go back and scroll through this at once. I'm laughing too hard. Have I gone too far? Am I the right amount? Have I not gone far enough? Let's check. All right. So we've got 6 starting from, this is week 6. It's right here. Okay. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I'm getting that her parents for that week would be $41,943.04. Even if her parents are billionaires, they do not want to be paying their kid $40,000 a week, which would double to 80, and then over $100,000. She would make 6 figures every month until she made 7 and then 8 figures, and then all their money would be gone very soon. So is this a reasonable agreement for her father to have made? He thinks so initially. He thinks he's outsmarting Mary, but no, it's not. Okay, I'm so nervous to hit check. If I miss this, I don't know if I'm going to redo it because it's just so much work. You see how to do it. Please show me that green check mark. Please, 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 please. Yes! Yes, how did I know I got it right? Because up here I saw my green check mark first, which means I got the entire problem right. Whew. Yay, yay, yay. Okay. One of those down, 2 more to go. We have some more little fun word problem scenarios here, and I'm going to cancel out each one of these X's because I need my space for this problem. Wow, this is a very fitting problem for the times we're living in. Let's listen to this. I've never taught this in my 9 years in a time like this where it's so applicable. Here we go. A contagious illness spread through a city. Wonder what that reminds me of. It began with 3 people who had the illness. Each day, 6 times as many people acquired the illness. And I will say right off the bat that this has been such an interesting problem every year. And people always say, oh, wow, what if that ever happened? I can't believe how fast it spreads. Yes, now we're seeing the reality of that. If you've been in my math class, we've been preparing for this for years. We start at day 0 as always. Go up by 1s each time. I'm just going to simply fill that in first. You can hit tab a couple times too if you don't want to keep clicking. And then for me it says it began with 3 people who had the illness. Again, you might have a different number here, but notice what it says. Each day 6 times as many people acquire the illness. Right off the bat, I'm just going to type in my start value is 3, my multiplier is 6, and then I'm going to figure out my numbers. So I go 18 after the first day. And then I just keep going. So 54. Each time multiplying by 3. 162. 486. 1458. And by day 6, over 4,000 people have it. Hopefully it's not that deadly, but with this disease, you just don't know, and the one we have is a great example of that. All right, we keep multiplying by 6 until we figure out how many days until 800,000 people, till at least 800,000 people have been affected in the whole town, which, as it says, this is the whole town. So here's what we do to build that herd immunity, as it's called, we know now. We're not going to get exactly 800,000. We're just going to see the first day where it's over that. So day 7, it's at 26. Day 8, it's at that. Day 9, it's over 800,000. It's 944,000. So let's make sure I counted it correctly. Like I didn't do. So 6, 7, 8, 9. Okay. Day 9, assuming I've typed this in right. Show me that green check mark again on the top left. No! Did you out there see my mistake the whole time? Were you yelling at the screen as I started multiplying by 3 instead of by 6? Again, I looked up here, I saw that orange check mark, I knew I was only partially correct. I'm going to have to redo this one. This whole assignment is an ode to my graphing calculator, where I would just be able to keep hitting enter each time, and it would spit out the answers, and I wouldn't have to do this copy paste thing. There's just too much to keep track of. All right, 2 people start, 3 times as many get sick. Ironically, it's like the problem's laughing at me. Now I'm multiplying by 3 each time. All right, 18, 54. Now, the exact spot I messed up is now the spot I'm going to be typing in. 162. Even just a basic scientific calculator would work like this, where you could just keep hitting enter. $14.58. All right, and I need until 500,000. So 43.74. 39,000. We're getting close, people. 118, 098 times 3. There it is. Okay. So that would be this is day 6. So 7, 8, 9, 10, 11, 12. Day 12. Come on. Show me that green arrow, check mark, whatever you are. Oh, thank the Lord. All right. Number 8 is a connection to science. Well, the last one was technically science too, as we race to find a cure for this disease. Write your answers as decimals rounded to the 3 decimal places if necessary. The half-life of a radioactive element is the time it takes for 1/2 of the atoms of that substance to decay into another different element. A certain substance has a half-life of approximately 20 minutes. If a science experiment started with 550 grams of the substance, after 60 minutes, blank grams would remain. Half-life means I'm multiplying by half, or 0.5. So I start with 550. So for you, type in what you start with. And then if you multiply by 0.5, for me, that will be after 20 minutes. So I'm going to count by 20s here. So 20 minutes, and then after another 20 minutes, that's be 40 minutes that have passed. It's going to keep multiplying by 0.5. And now we have 60 minutes, which is what it asks. After 60 minutes, what am I at? So I'm at 68.75. And then for this one, let's just simply keep going until we get this number, and then we'll count at the end how far we've gone. So if I multiply this by 0.5, I get that, 34.375. Let's start copying and pasting this. I'm really tired of typing it in when I'm used to just hitting enter, and it gives me it perfectly each time. I'm whining so much about my graphing calculator, but I just miss it, and I've made multiple mistakes on an assignment. I think for the first time since I've started doing this, all because I'm away from my technology. All right, so there's the number we want. And now we have to count how many minutes have passed. Well, we know that each half-life is 20 minutes, so let's see how many half-lives we've gone. So starting at the top, 1, 2, 3, 4, 5, 6, 7 half-lives I have gone. And each of them represent 20 minutes. So that would be a total of 140 minutes that have passed. I apologize for how long this video is. It's 25 minutes because each of these problems takes a while, and it especially takes a while without my yellow graphing calculator. I miss you so much. But in the end, we got the 100. All the problems are explained in great detail, and some of them multiple times because I got the first time wrong. I'm going to end this video fast. Have a great day. Thanks for watching. Sorry it was so long. Peace.